Okay, so how's everyone doing today? Good? Okay, cool. Very cool. So I, however, am freaking tired. Flew in here last night from Austin. I made the mistake a couple months ago of quitting caffeine, which is the stupidest thing ever. I know. Yeah, what are you going to do? But so I'm here to talk about a couple of things I'm pretty passionate about today. First one is continuous integration and test-driven development, and that's in the context of network engineering. So when John was up here talking to y'all this morning, he asked a question like, who's a software developer, who's a network engineer? I was sitting up here so I couldn't see everyone, but who's a network engineer primarily? Okay. So who is familiar with, and the network engineers, who's familiar with the concepts of continuous integration and test-driven development? Wow, okay, so we've got about half the network engineers. Who is not familiar with those concepts or those tool chains? Okay, so we got a couple of people that will add some value to. Okay, cool. So what I want to talk about today, I have nothing to sell you. I work for a company like everyone else does here. If you want to talk about that, about my company, we can talk afterwards. Talk about a little bit what drives my perspective. So there are little minor things about what I do that's buried inside of there. I want to talk about the whys for test-driven development and continuous integration for network engineering. I think the whys are very important. One of my goals coming out of this is, a couple of years ago, I started developing for a little cloud platform called OpenStack. And it was my first real exposure into modern software development. I'd been an ops guy on a dev team prior. Gosh, years ago, I'd been ops guy 2000 when it came to the Bay. But I hadn't actually used a lot of these tool chains. I hadn't seen the benefit of agile software development methodologies until I started trying to cram patches in and failing at it all the time. So one of the things that was good for me as a network engineer, as a CCIE myself, is that I was able to take that viewpoint of how a modern app dev team was working and then apply that to the concept of how a network operations team works. So talk a little bit about the why, and give a little bit of an overview of continuous integration and test-driven development. For the people that haven't learned about it, it'd be a good primer, a good start. For those that don't know, you'll probably fall asleep. That's fine. And then I want to go through a network change management use case, specifically with some of the operational maturity levels that I use internally. So it's kind of what we use internally in my own business, and then we help other people with too. And they'll all be up here for download if you want to use them yourself. Okay, so who am I? My name's Colin McNamara. I am the Chief Cloud Architect and Director of the Cloud Practice for a company called Nexus IS. We're a division of Dimension Data, this big, ginormous global conglomerate that bought us about 4 months ago. Know a little bit about them, but not that much, so if you know them, tell me. I'm an OpenStack active technical contributor and an ambassador. Core reviewer, I manage a development team rolls up to me as well as an agile consulting team internally. I'm a beard growth specialist, and yes, I am training for competition. Has anyone seen Whisker Wars on Netflix? Yeah, actually I'm getting accepted into the Austin Facial Hair Club, which that's based off. Score. I'm a CCIE myself, so I've done a bit in web scale. There's a couple people from Cisco that I've known across the years where we've done some pretty big things or worked together doing some things in the past. I'm also a systems engineer, so I started as a systems engineer years ago, ran a dial-up ISP. So it drives a lot of my perspective. At work, I spend most of my time, actually I don't know what I do anymore, but I speak at a lot of things and help people be awesome. My teams, we focus in upstream software development. We're in OpenStack, Open Daylight, doing proprietary and non-proprietary SDN controller implementations and integrations. 50% of the work my senior devs do is required to be upstream. So I think that's something that gives a little bit of perspective in DevOps. I don't claim to be an expert in this stuff, but I've been really, really lucky to know people like John and others in this space over the past couple of years. Talk more about that if you want to. But fundamentally what my team does is we make unicorn farts. We write code. We write network code, SDN-centric code. We do systems integration deployment code. Do a lot of work with proprietary network platforms like NXOS, Open vSwitch, SDN controllers like NSX and ACI. So that's what drives my perspective, and I hope it gives a little bit of validity to what we'll be talking about. So fundamentally, why test-driven development and continuous integration for networking? It's a very, very simple question. A couple of years ago, I wouldn't have considered actually using a CI system to proof all my changes. So now in networking today, and here JR, which I was actually really stoked and scared to come after JR, because JR was one of my heroes. He has him, Dinesh, Matthew, some of the guys at Cumulus. They're just amazingly brilliant people that are some of the brains behind a lot of the network gear that we've used over the years. But things are changing with how they built systems back in the day. things are changing very, very severely. Fundamentally, there's a couple core concepts that go closely together. Agile software development, software-defined networking, cloud computing, and DevOps. Now, what happened back in the day, and I know when I came up as a network engineer, I had a very, very strict expectation of what I was supposed to do, what the performance that I was supposed to do in my role, how quickly I was supposed to have a ticket closed out, how stable I was supposed to build a network. Back in the day, in the classic world of networking, I could get stuff done in a 12-month, I had a 12-month lead time. You know, you had your yearly projects when you remember those days, right? Do you? Yeah, wasn't it great? You're like, very chill, yeah. In 2015, I'm going to buy not only one firewall, but 2 firewalls so I can cover one up if it fails, right? I'm going to implement spanning tree or maybe Trill, right? But you had time to actually build stuff. In reality was, you know, a 6 to 8 week lead time for implementing a portion of your infrastructure was pretty much accepted, right? During those days, just like all software development back in the day, your QA was pushed to the end. You would build it. You would sometimes write, you'd have a set of templates, maybe scripts if you were lazy like me, or other people that may have, you know, written cool things like NetDev and other things. Jeremy's nodding there. But what allowed you to do is you would be able to build infrastructure up, test it at the end. You'd end up with network ready for use testing. If you're doing anything web scale, you might bring in like an Ixia or a Spirent box, and you would go ahead and work out all your bugs and then bring it into production. That actually worked good. Network engineers like us were able to accomplish our jobs in that context. We're able to do our jobs without getting fired. So now let's fast forward in this current day, right? So one of the things that came out of that was you got that handoff, right? How many times did you throw a firewall, a load balancer, a services layer into production, and then the app dev team sent it into you, and they're like, yeah, it's a network fault. It worked fine in development. Who's had that happen? Everyone, right? So now let's fast forward into today, right? So we got some old infrastructure that we had to make very, very flexible, right? Jared was talking about the pain points of NXOS, and I can talk in depth about the pain points of NX API. And if a couple of my developers actually make it down the South Bay, they can complain like all get out. But you're really looking at moving from 12 months down to about 2 weeks if you're lucky. So it's hardware procurement, and the expectation is that you're going to throw the gear into production almost immediately. With modern development and infrastructure and application development, I kind of tie them together. That really the QA becomes integrated in the process. And we'll talk a little bit more about the notion of nesting your tests, the application, and the infrastructure together. And when I look at in the context of software-defined networking, and we can throw out like the manufacturer terms around SDN, using software to configure the end state of your network, right? It came from a file, right? The notion of you have your test that validates the infrastructure performs as specified, and the applications perform in the same manner. They're tightly coupled together and that run forever with those systems. Problem with this is it doesn't map into the siloed processes we'd had before. It doesn't map into the siloed teams. You don't have your network team, your systems team, your database team, your applications team. You actually work pretty closely together. Now, for a network engineer, especially if you work in a large infrastructure, those silos may still exist. Has anyone seen those silos? One, are you a network engineer that works in a large company or with large infrastructure? I am, right? Do you still have those silos? Yeah, it sucks, doesn't it? Yeah. Does everyone like kind of hate each other sometimes? Yeah. Right. So in the new world, very much aligned. I call it cloud aligned and other overused terms, but really agile aligned. So when you come out of this, when I see this shift happening from kind of the old network engineering, the old systems engineering, the old application development, what you end up with is kind of like Speed Racer. You end up with a set of integrated tools with QA integrated in the system. You end up going ahead and moving in systems, and we'll go over a walkthrough of what these systems are and kind of how logically they happen. And the code ends up rolling forward step by step. And you notice I said code, not configurations. So who actually looks at their network configurations and treats them as source code? Okay, who treats them as configurations, maybe puts them in Dropbox? No? Okay. So it's one of these really important concepts that really clicked on me quite a few years ago. Actually, my last startup, ID Analytics, it's the backend for LifeLock now. We're doing high-dimensional mathematical analysis of financial transactions, and the network infrastructure was inherently built into the application. At that time, we started checking things in, right, in the subversion at the time, and it makes a lot of sense. This notion of your infrastructure, even your configuration files are as code, starts progressing as you move on to working with software-defined networks, even working with old networks in a software-centric way, that your infrastructure is code. So I say that DevOps is the new network operations. If you look at some, Jared was talking about his experience at Google. This was systems operations at scale that were tightly coupled with their development teams. They were able to go ahead and not only lower the cost of their network, but increase the performance and productivity of their network, right? If you look at Facebook, if you look at JP Morgan Chase, if you look at Bloomberg, right? Where's John? He could probably name off about 30 banks from his last life. But this notion is that everyone's facing a very core truth right now, that if you're deploying any sort of SDN controller, and I'll ask, is anyone looking at or deploying Open Daylight, NSX, or ACI? Okay, so about half the room. So if you're deploying any of these SDN controllers or models, there's one truth that you'll face every single day, is that you make one change in one file, and you can either destroy a system or create a system. Just fundamentally. You can blow it up like that. It is just the truth. So what if you could actually know that everything would work before you made that change? So when I say no, I don't mean no. My gut says it'll work. I think it'll work. But what if you could actually validate it? Has anyone, does everyone here, raise your hand if you actually do this, test every single change that goes into your network? 1, 2. Okay, JR, you put yours through a CI system, so what's your test coverage, JR? Pretty good? Above 80%? I bow down to you. Well, I would bow down to you beforehand, but but this notion of being able to actually write a test that validates, hey, this VLAN actually works. Hey, this server can actually ping to where it needs to. Hey, if I impose a security control that only let port 80 through, that, I don't know, port 80 actually worked, and the negative test of port 443 didn't work, right? This notion of actually asking a very simple question. Who here has been in a change control board? Okay, only 10 people, okay. And who here loves being in change control boards? No, they suck, right? So, and what's the single most common question that I've heard in my career in a change control board is the app guy or the VP of IT, whoever, saying, will this break my application, right? Has everyone experienced this question? So how many times are you actually able to answer that question, yes it will, or no it won't? Most of the time you can't, right? The really interesting thing about using test-driven development and continuous integration is you have these things called dependency mapping, right? This notion, if your application was developed and deployed in the same way, in the same manner, on the same tool chains, you can actually map those two things together. The code that dictates your network change, the test that validates its function, and then the test that actually made sure that the application worked before it deployed. And whenever you make a change in either of those two dependent items, that the test will run. It's actually a nice little, it's a safety belt. In my development team, what we describe it as our QA developers, not QA engineers, actually QA developers, or not QA testers, is that our tests are like seat belts that we put on ourselves so we can drive faster and faster and faster. Writing code without test, managing a network without test coverage is like driving a Ferrari without a seatbelt. Eventually it won't work out. So that is, I ask a fundamental question, what if you could test every single change? To be able to accomplish this goal, however, it takes a lot of changes. You have to change the people that you use, there's the skills that you use, right? How you do what you do. And remember, I'm a network engineer. I'm not suggesting fire everyone, get developers in. What I'm suggesting is that you have to learn new skill sets, learn how to use new platforms. You have to change the processes that you use, and you have to change the technology that you use to be able to achieve these goals. And some of these are proprietary, but a lot of these are in the open domain and freely available for you to use. So we'll talk about, let's talk about a little bit of the process, a little overview of CI, right? So for the 10 people that raised your hands didn't know about CI, and there's probably 10 more that didn't want to raise your hands. So fundamentally, come to the dark side of software development. We have cookies. It's really fun. We get to use Nerf guns. We get to do things like pair programming. We have a lot more coffee, and we get to hang cool posters, right? Although for guys like me who don't drink coffee, it creates a problem. So what we're going to talk about is this process. What I'm not going to, however, do is go over all the different steps in here and use a different spaghetti chart. When I first, actually, when I was getting my first patch into OpenStack, I was with a guy, Vinay Benai, does SDN over at PayPal. He was over at AdTrend still, I think. We actually were trying to figure out the process that OpenStack uses to merge code. And this is actually the process that OpenStack uses. It's really scary. It's really scary, it's really confusing, especially as a network engineer. It is entirely different than how we've done in the past. So we're going to go over a slightly simpler walkthrough of this to get some concepts. And hopefully what this will allow you to do is build on those concepts, break down the fear, be able to do a little bit more research in the future, and be able to use these in your own infrastructure. So fundamentally, if you are putting a network change in, let's just use a simple use case of a VLAN change. It is the most common fundamental component of network changes, whether it be on a software vSwitch, whether it be on a physical switch. We're going to give access to a different layer 2 domain. Now, whether this is a software representation of a VLAN or implementations, doesn't really matter. So in this case, what we did is we had the delivery team, this would be you, by the way, a network engineer, checked into version control. So you would go ahead and write your code, say switchboard access VLAN, whatever. You would check it into a version control system. Most people now use a tool called Git. That goes and gets picked up by your CI system, your continuous integration system. And it goes ahead and runs it through a series of build and unit tests. Now, these might be very simple tests. It runs through a linter and make sure it's structured right. Make sure there isn't a tab inside of your code. Very simple, lightweight tests. Just make sure it'll work. Maybe you would go through and run it through a simulation of how it would apply it. At this point, you see there's a red light, right? Passes it right back to start. So it's kind of like chutes and ladders for networking, chutes and ladders for software development, right? So you end up going down your chute every once in a while. At this point, you get a set of feedback. It would say, okay, well, your code was wrong, or you messed up your PEP 8 standards if you're doing Python or whatever. So you as a developer then would go ahead and fix your code. And this doesn't require like peer review at this point. All it does is just automated feedback from the systems. But what didn't happen is that code didn't get into production, right? So this is not one of those seatbelts that you put yourself through. At this point, you go ahead and fix your code, and you go into automated set of acceptance tests. Now this is normally building a production system. So getting back into that first concept, when we had a very long time to build a network, you notice a simple thing here. For continuous integration to successfully happen, right, to use these modern software dev technologies, you have to programmatically configure your network. There is no other option. There is no other way to be able to move at this speed with this high quality without programmatically controlling your networks, without implementing some notion of SDN. Not saying a fancy controller, even writing an API, writing an API of your network equipment, right? So these automated acceptance tests are building the entire thing Now, this may catch problems like maybe you gave access to the wrong VLAN, right? Maybe you put everything on VLAN 0 and your security team put in some very simple security tests to make sure that things weren't, actually there's no VLAN 0, but VLAN 1. Actually, no, there is VLAN 0 in some other products. Looking at the Cisco people there. So say that failed and you didn't pass the functional test of your network, it would go ahead and pop you right back. Now, this actually happens quite a lot. It happens to me when I'm submitting code all the time because I'm normal, I'm human. And you actually get used to having these tests, these safety checks. At this point, the system, you submitted your code with the checks, end up passing your triggers and pass your automated acceptance test and going into either your user acceptance tests or what a lot of people do is, like once you get up past your automated tests, a tool called Jenkins, I'll get in a little bit of tooling discussion after this. We'll go ahead and say, okay, you passed all your checks, and you'll get into peer review and your manager review, right? At that point, your other network engineers, your other developers will look at your code, make sure it's properly commented, make sure that documentation was uploaded with it. Sometimes you do that as an automated test, and then it passes it through into production. And what's really interesting is you're releasing to production is no longer with a human. It's using those same tool chains that you used to build in each of these environments. So you're building unit tests. Sometimes you don't use the same tool chains. But these automated acceptance tests, you're actually releasing onto a router, onto a switch, onto a controller. And so those same tool chains that you use to release into development are releasing in your production environment. Now, it's really, really handy. So what you end up with is a set of safety checks, consistency in your QA environment into production environment, and at 3 a.m. in the morning when you're drunk and you get the call, we've all had it, you can just You've all had it. Might have had it last week. You can literally press the unscrew button, right, and just release go to an earlier release. So this is a simple example of CI, but you can get much more complex into it, and happy to have those discussions, and especially when Maglana shows up. He's a test-driven development expert, one of the guys that works on the teams. But so does everyone have just a clear understanding of the basics of the CI walkthrough here? Does anyone have any questions about this? No? Okay, I'll be around. So next, got to talk about tools. So it isn't a DevOps talk if people don't talk about tools. So most important tools out here, all right? Okay, so wait for anyone who knows Joe Onisick. So yeah, there's a couple small tools in Jersey, and there's a really big tool that works on Tasman there. And someone let him have a Twitter account. No, just joking. He's a really good friend of mine. I don't know how he got his job, but you know. So tools discussions. So I'm not going to talk about a lot of specific tools here. There's a whole suite of tools out here. But for those that are kind of new to it, I thought it's good to do a little primer. Git and Gerrit. So this is my daily view. What Git and Gerrit is, so Git is Linus Torvalds, who created Linux. You might know him. You might know the project. Got really sick at Subversion, so created a distributed version control system, which makes it so you can work on code while you're in an airplane or at the lake, right? So Git absolutely is used every day by most teams that are doing any sort of upstream development or open source development. I really recommend that you implement it in your own place. It's also free. Gerrit is a governance tool that allows you to go ahead and integrate code review. Again, is also used in most upstream projects and can be used in your own infrastructure for free. Next tool chain, and a screenshot of our own systems today. Had to hide a couple of things on here, is Jenkins. So this came out of Sun Microsystems as a project called Hudson. It is, again, used in a lot of upstream projects, OpenDaylight, OpenStack, a whole bunch of fun stuff, and is really, really handy. It has a rich plugin ecosystem into it. And most likely, if you're not a Microsoft shop, is probably used by some of your developers. These tool chains, Git, Gerrit, Jenkins are the primary three that you're going to see. There's a whole bunch of other tool chains that are out there available. We can have that discussion. But if you're going to implement something like this in-house, I'd really recommend it. Other things that are really interesting for a network engineer. So this notion of, when we talk about the build and unit tests versus the functional test, and I need to actually build out a better list here. And sorry, JR, I didn't have anything that directly related to Cumulus in here. But the reality is, for most network engineers and larger install base is going to be between Cisco and Juniper. And a lot of the web scale and forward-thinking enterprises are looking at Cumulus also, right? Cumulus and other open networking stuff that it can run on. But there's some really interesting stuff. So what formerly was Viral, which is now Cisco Modeling Suite? Cisco Modeling Lab, thank you. Thank you. Okay, so this really smart guy, Ian, who's a developer in OpenStack, works at Cisco, created a lot of the back end on that. It's basically deploy Cisco virtual images, the -v images for all the routing operating systems onto OpenStack. And you can basically go ahead and hack it really easily to prepend and append a whole bunch of topology information and directly work with, build a topology and test it as part of your functional test. Really, really interesting, and especially if you start using different abstractions like TailF, or I think Jeremy's might be talking about some Sprocket stuff, or Puppet or Chef or Ansible, allows you to go ahead and directly interface with a real routing operating system. Same thing is true with Junisphere, which is a hosted version, something very similar on the GNOS side. Other things which are really interesting, and I actually got my teams teed up to start looking at actually doing integration on this, is Mate and WAE on the Cisco side. So it allows you, when you're not just making a VLAN change, but say you're making a change to a production network with a lot of traffic onto it, and it's a service provider network. So you can actually go ahead and model that change where, if you're going to influence traffic distribution on it, maybe you're going to influence other customers, or you're going to take out an application. So interesting things that can be directly integrated with your CI pipelines. Now, if anyone knows any open source projects or any other things that accomplish similar goals, please tell me. I'm going to add them to my decks and also add them to some of the things we look at work. So the last thing I'm going to go over here is a use case for continuous integration. And we'll go over a use case for change and release management, and then step through a couple of the operational maturity levels that I use internally in our DevOps transition. So we're a couple of years into it. And we've been doing active SDN development since last summer. So I think we started with OpenFlow with Cisco's extensible networking controller, and then that became Open Daylight, and moved into some other SDN platform integrations, as well as OpenStack development. So who's seen this process before? Yes, we've all seen it. So this is the change and release management process that if you're an ITIL or ITSM shop, you have to do every single day. Sorry about cussing and using ITIL and ITSM, but they are a reality to most network engineers, especially out of Silicon Valley. So one thing that is very interesting is that when people see the old infrastructure management, they believe that DevOps doesn't work with it, right? Or you get the gut feel is, oh crap, I can't use DevOps toolchains. Well, it's a little hard to see here, but in each of the different steps here, what I've done is highlighted each of these tools, the tools in the chains we talked about before, how they can use to integrate into the process, but also to better fulfill the tenets of ITIL and ITSM. It's really, really interesting. You talk to an ITIL specialist or an ITIL or ITSM shop, and they'll say, oh, you big bearded DevOps hippies, stay out, right? The reality is you can make sure that things are tested, things are validated, things are properly approved and properly deployed in a much better fashion. Personally, I've used this matrix we created internally, stole a lot from Jez Humble at ThoughtWorks, who's a brilliant, brilliant man. A lot from oh gosh, man, they got bought by IBM. I already forgot their name. Crap. A couple of, I'll remember when I actually get sleep. So there's a couple of the, basically what we've taken is some of our own experience and as well as some of the best practices in the industry over the couple of years. Build our own operational maturity matrix for how we operate internally. So what I will go through here is just a couple steps that if you do want to implement continuous integration in your networking or systems, that some things that you can do to go ahead and get there. Now, first things first, you'll notice there's a management visibility, QA, operations, and development called out here. So normally what people do is they get really lazy, and they either do development and operations, and they go straight to the right, and about 6 months later, you get this call, or you get this tweet, you get this email, and say, hey, our velocity dropped. We're not doing anything anymore. It seems like we can't grow out of a single team. What commonly happens that I've seen is that people forget QA, they forget management visibility. They just go straight to writing scripts. They're like, hey, great, we implemented Puppet in our system. We implemented Ansible. We're DevOps now. The reality is you're not acting like a software development team, and your transition will stall. So first things first is let's talk about level 0. And sorry if this sounds like a management consultant. I do run a business internally in my own business, and I'm responsible for getting out from the center of excellence to the global organization. And looking at it in this way, one is a very structured way of achieving your goals, but two is actually a way of communicating outside of your team. So first things first, you have to go ahead and address the development side, right? So very simple. Now, as network engineers, we do this all the time. We create standards for our service chains. Those are our templates, right? But a lot of people don't. So we have to go ahead and we have to create them, but then we also have to store them, right? You have to build value stream maps of your specific IT processes. So has anyone created a value stream map before in their life? Okay. So here's some homework. Everyone take up your phones. If you really want to do this, go to Amazon.com and buy a book called Learning to See. It is a great book. It's a manufacturing optimization book. I know John recommends it all the time. Forgot who recommended it to me first a year or two ago. What's that? You have a what? You got it from Damon? So the whole point here is there's a lot of changes that sometimes that require the time investment from people or money investment. And there's some things that we do on the software development side, but it actually comes from manufacturing background, which is to go through and look at where your work impacts the rest of the business. It's a simple thing you do with a pen and paper. It's not a management consultant thing. What it allows you to do is go ahead and say, okay, well, if I automate this simple VLAN change, or if I automate this simple firewall deployment change, that I can double the process efficiency in the business, or I can take something from a month to a week. It is a way that you continuously measure the process improvements that you implement. And from a management visibility side, it is key and critical to getting support. On the operations side, very simple things. So you start scripting deployments, right? So you have templates, and use a script to apply that template. It sounds very simple, but it sounds like it won't get you there, but it's kind of baby steps, right? On the QA side, It's very simple. So who actually builds test harnesses to validate what they've deployed? Any sort of script that pings. Okay, so very, very simple start. So if you haven't started writing either Python, I won't say learn Perl, but Python, Ruby, let me see, a lot of people are starting to talk about Go, but probably not for a network engineer, wouldn't recommend it. But learning Python and writing some simple things that ping across your network and write it out to a CSV file, very, very, very important. But what it'll do is it'll start building these tool chains, a set of scripts that your system can automate over and over again. After you start using source control, just check in those configs. And moving into the QA side, start modeling something. If you have a physical lab, go for it. If you have a virtual lab, use it, right? And then on the management side, does anyone use any Kanban boards or any sort of lean or agile tools for their own workflows? Okay, so if you don't, so internally use a thing called Scrumban. One of the best things you can do is start getting visibility into all the work, because it never fails as a network engineer. You have project work, you have maintenance work, and you have the oh crap, it's down work, right? And then you got your buddy just called you work, right? And a lot of times those aren't tracked. And if you're wanting to actually run a development team for your networking organization, you're going to have to start getting visibility into all this work. It actually is going to map back in all the changes. Next level is simple level 1, where you start getting, where you start doing nightly builds, right? So it's implementing Jenkins. Now, if you don't have to implement these from scratch. There's a lot of Puppet code that can actually do this. If you want to implement some of it yourself, you go to github.com/nexusis. Has all of our Puppet code up there. Part of the Denica stack is a fully implementable CI system. It's free. Take it. Oop, I lost it here. So in level 2 here, so you start using the scripts to build your development environments on demand, right? So you have to be able to have a virtual environment, ideally. You have to have a scripted build, and then have a system go and automatically build it each night. On the ops side, you end up deploying via configuration management. So this is Git, or excuse me, Chef, Ansible, Sprockets maybe, I don't know. This is some cool stuff. And by the way, I keep talking about Sprockets, so a lot of the network configuration stuff through like Puppet, or a lot of the network vendors are going to talk about Puppet NetDev. Jeremy here wrote Puppet NetDev that all the network vendors do, and he's starting his own company, Sprockets, and he's kind of smart and stuff. So I would listen to him when he talks. On the operations side, you start implementing processes like your review of differential configurations, where JR was talking about bite-sized code that is easily peer-reviewed, right? So you end up doing that in your teams. On the QA side, again, you implement the CI systems, and you start implementing some common functional tests. Does this network function? Do I have an end-to-end test? Can I test for a specific use case? And on the management side, you start consolidating visibility of people's Kanbans, right? So this starts, you have your individual Kanbans you started with just to kind of figure it out on your own. Then you start combining your teams together. And you start getting a lot of cool visibility. Now at that point, when you get to level 2, this is probably the point where you can actually use your CI system for deploying into production. It's not that hard to get there, but it takes a lot of work, right? Or it takes an amount of work, but it's not impossible. So you end up implementing the CI system together. So basically what you end up with is where you can submit into source control, a system automatically builds your system, and then integrates it with some sort of governance controls to make sure what you put into production is actually supposed to be there. On the operations side, you end up having a CI chain your CI chain is integrated into the release into production. So in level before, you may have been using it through your QA lab, but not using it into production. You still have a human typing it in. At this point, your QA team or your operation teams are using the same system deploying to production. You get a little bit of consistency here. And that you end up, you're having a standard, as much as you can, standardized abstraction in your QA environment to your production environment. So that's hopefully using the same level of config management. Whatever tool chain you use, that's your choice, right? On the QA side, we talked about a little bit of this, but very important is the system's, the system building all this is actually emulating your applications inside of it. It's very interesting. We've all run this. A network without applications is not really a network. It's just a thing, right? And on the management visibility side, rolling up multiple teams into the different team boards, pulling, if you are an ITIL shop, actually moving the KPIs into this. A plug, if you, Red Hat's actually using code from us right now. It's called Project Rosetta. Again, if you go to github.com/nexusis, we have tool chains that if you use a tool called Trello, actually, who uses Trello? Okay, has anyone pulled information out of Trello and noticed there's gaps in it? Oh, you haven't. So if you pull CSVs out, Trello is optimized for security and speed, not accuracy. So if you're actually paying people or maybe using that for people's MBOs, you're probably going to be in trouble. We wrote a tool that normalizes all this. It's upstream. It's open source. So it's called Project Rosetta, and it's up there. So key takeaways here. So test-driven development is all about quality and velocity. It is about writing the test before you write the feature and having the lights turn green. What that allows you to do is it puts on seatbelts. It makes it so you can drive your infrastructure faster and faster and faster each day. Makes it so you can make that change at 3 a.m. without having to worry, did I screw it up? Network design and operations absolutely benefits from using agile methodologies. Fundamentally, you have to make a shift in your mind that I'm now a software developer. I'm not a network engineer, but I'm both, right? And that if you do actually want to get there and you're going to try to get there, one of the biggest mistakes you can make is just working on scripts, just looking at deploying a state in your network. But if you define an operational maturity model, if you address the areas of design operation or development operations, QA, and management visibility, that you'll start acting like a software development shop. And this is exactly what you would do if you were actually running a software development team, but you can implement it in network engineering. By taking all these 4 things together, you can start your transition yourself. So have fun building your systems, and I will give my time over to John.